There is no practical value in learning biology in my life. To what extent do you agree with this statement? You might have heard the slightly different versions of this assertion, that replace biology with history, philosophy, classics, and so on. Liberal arts, such as social science and natural science, may seem to lack pragmatic utility, and nothing more than intellectual entertainment. You might rather want to learn tips for climbing up the career ladder, or visualizing your way to being rich. Although it may seem less straightforward than books of the self-help genre, learning liberal arts can actually provide profound insights into humans and society that will support and enrich your life. For example, the knowledge of life science will deepen our insights into human nature and society, help you challenge the traditional idea about organizational management, and bring about essential humility and maturity. What kind of lessons can we draw from life science? The common typical image of organizational management is probably command and control. It is a hierarchical system, where upper managers are in charge of making decisions and taking responsibility for their decisions, and subordinates follow these commands and execute them. Today, many companies adopt this concept, but they don't necessarily have to work this way. Learning life science suggests another possibility of how organizations function. In fact, some of the innovative business leaders use the metaphor of a living organism or an ecosystem when they talk about their organization. For example, our bodies consist of about 40 trillion cells that are working collaboratively but autonomously without any central command. The human brain has 100 billion neurons, but there is no president neuron that directs and controls the function of other neurons. When we hear someone speak, neurons of the auditory cortex automatically start working. It doesn't receive a command from the prefrontal cortex, nor have a discussion with the amygdala to form a consensus. Likewise, some companies thrive without top-down management. Any member in these organizations, regardless of their position, is empowered to make decisions by themselves when they feel it's necessary, as long as they seek advice from people with expertise and people who will be impacted by the decision. Companies like Buurtzorg and Morningstar have successfully operated this way, despite their scale of more than 1,000 employees. There is an exceptionally famous book called The Selfish Gene, written by the biologist Richard Dawkins in 1976. The title of the book is somewhat misleading, giving us an impression that living organisms are inevitably selfish and egoistic. But we often get him wrong. He meant that it is genes that are selfish, not individual creatures. If we take a closer look, it often turns out that acts of apparent altruism of the individuals are actually selfishness of the gene in disguise. In other words, altruistic behavior by an individual for the benefit of the community sometimes coincides with the interests of genes. Take an example of the stinging behavior of worker bees. This is an effective defense against honey robbers, but they are like kamikaze fighters. They die soon after the act of stinging. This suicide act appears altruistic on an individual level, but it is actually beneficial for the genes. A social insect colony is a huge family, usually all descended from the same mother, and all bees in the same colony share a similar set of genes. If the act of self-sacrifice benefits the other members of the colony, it makes sense in terms of survival and propagation of the genes. Altruism within a group often goes with selfishness between groups. Genes might be inherently selfish, but paradoxically, individuals can exhibit altruism because of the selfishness of genes. We Homo sapiens are quite interesting animals in terms of altruism. A number of studies on psychology and behavioral economics have demonstrated that we often disregard our personal economic rationality and behave in favor of others' interests. This is probably because humankind is a species that have survived and thrived by trusting and cooperating with each other. Biologically speaking, there is nothing particularly special about our bodies and brains. We are genetically very similar to our closest relatives, chimpanzees and bonobos. Neanderthals possessed larger brains and bodies than Homo sapiens, and researchers speculate that they were superior to us in both physical and cognitive abilities. However, chimpanzees are locked up in zoos, and Neanderthals became extinct, while Homo sapiens enjoy unprecedented prosperity. This is because of the simple fact that we can cooperate more effectively than other species. Our ancestors effectively cooperated to hunt large mammals that any individual hunter could never bring down. Instead of everyone making both bows and spears only for themselves, people specialized in making either bows or spears and exchanged them, thereby each of them saved time. The same is true today. We are all dependent on the enormous network of cooperation, and nobody can live alone. What defines Homo sapiens is trust and cooperation. We have survived and thrived by trusting each other, sharing skills and knowledge with each other, and contributing to each other. Thus, it is no wonder that we are genetically hardwired to be social. We feel happy when we receive gratitude from others. We get motivated and engaged in our job when we find its significance for society. We become even physically healthier when we have good relationships. You will inevitably come to realize that only caring about your own success or well-being never brings about happiness in the truest sense. This is not sentimental idealism, but biological reality. There is a famous phrase that says, "Nice guys finish last," which means that those who behave kindly and trustfully will lose out in the end. But will they really? We can examine this proposition from a biological perspective. An American political scientist, Robert Axelrod, used the famous prisoner's dilemma as a basis with some modifications, and he simulated on computers the reproductive competition of individuals, taking various cooperative behaviors. In his simulation, when two individuals cooperate with each other, the both can benefit pretty well. When one intends to cooperate but the other betrays, the betrayer enormously benefits and the other loses out. When the two betray each other, both of them lose out a little. Each individual leaves a number of offspring in the next generation that is proportional to the size of the acquired benefits. After 1,000 generations of reproductive competitions, what type of behavior thrives and becomes dominant within the group? He ran the simulation several times, and in most cases, what succeeded the most was the strategy named tit for tat, in which individuals generally behave cooperatively, but can betray in retaliation only when they are betrayed. As the generation proceeded, nasty betrayers disappeared from the group, and nice cooperative individuals became dominant. Some of the nasty strategies thrived for a while. When the group was already dominated by selfish individuals, other strategies were exploited and struggled to flourish. But their prosperity was usually short-lived. In evolutionary terms, a successful strategy is one that has become the majority in the cluster, and for a strategy to remain successful, it has to do well specifically when it is the majority. Selfish strategies can occasionally be the dominant one, but they often fail to persist, because they cannot benefit from gathering and cooperating. At least in this simulation, nice guys finish first.